So yeah, that's the theme of the NxJU. It's all of the lights. We're going to do a lot of light stuff. We're going to light LEDs, we're going to light RGB LEDs, and you're going to learn to use basic Arduino. Basically this just small thing is just the lights are synced to the trumpet background in the music. It's not perfect. I think I have a beat extra at the workout, but anyway, that's it for the demo. And so to start, just very basically, you know, what is a microcontroller even? So a microcontroller is essentially just a small computer. It has a processor core, memory, and it has programmable peripherals, input and output. So this allows us to do things like hook up LEDs to it, and also hook up sensors to take in data from the real world and do something with it. They're used for like embedded systems, basically one specific function within a larger system. So you have many microcontrollers in a larger system is generally how they work. So what you have in front of you is called an Arduino Uno, and so this is what it looks like. Some things that we'll be looking at specifically is these are going to be our digital pins that we're going to hook up our LEDs to, and our power, our grounds are going to be the main things that we look at. Next. There we go. Cool. So the second piece you have in front of you. So if everyone, hopefully you have your things opened. The second thing is called a breadboard. Breadboards are cool because they're specifically solderless, meaning that you don't have to like hot iron the wires together. So you can just plug in what we call our jumper wires into them to connect things, which is great for essentially rapid prototyping. This is the schematic of how the wires actually connect in the breadboard. So typically on the right and left side, you have your plus for your voltage and your negative for your ground. So you'll supply your power through that way, and these things run vertically. So if you plug in something at the top and then something else at the bottom, that is how the electric current will run. Conversely, for the inside of the breadboard, it runs horizontally. So that's just something that we'll want to keep in mind when we actually start to set up our circuits. So before we actually start setting up any currents or any circuits, we have to actually talk about electrical circuits and a tiny bit of electrophysics. So what we're going to talk about is Ohm's law. So basically on your left you'll see a very basic circuit. What this is, it has a voltage V and it has a current I that runs through, and then R, that squiggly line, is what we call a resistor, and it goes back through a loop. That's why it's a circuit. It's a nice circle. And so basically why this is important, specifically for our LEDs, through the USB, before we plug these in, the computer will supply 5 volts of electricity. The LEDs can only handle 2 volts or 3 volts. So if you plug them in without a resistor, which does exactly what it sounds like, it literally just resists the current, so there's less of it, the LED will explode. I think Isaac was telling me before that he got a little too excited in his class that had them and just like plugged them in and it exploded. Very Isaac. So according to Ohm's law, so what we normally have to do is figure out what type of resistor we need, how many ohms it needs to be for our circuit. So the resistance is going to be equal to the potential difference in voltage. So what this is if we have 5 volts supplied by our thing and our LED can only take 3 volts, then our potential difference will be 2. We want to drop the voltage by 2 volts. And then over the current, which is in amps, and that's just going to be 0.02 amps for specifically for these Arduinos, how much they output. So first project. So does everyone have kind of their things set up or opened at least? Cool. I mean, definitely take a moment right now to open them. You can, if you want, you can affix them to the black thing. Not super important, but useful. And so first, while we're doing that, what we have to do is we have to calculate what type of resistance we actually need for this circuit. So what we have is you all have a mystery color LED, ranging from red to blue to green to pink. And so specifically for a red LED, if we look at it, it can only take 2 volts at our current of 20 milliamps, which is also 0.02 amps. And and like I said, our Arduino voltage through the USB is 5 volts. So if we go back to Ohm's law to calculate this, as you can see, we would just do 5 minus 2, 3 over our 0.02 amps, which will give us 150 ohm resistor. So that is the minimum resistance that your LED needs without exploding. So this will be the absolute brightest you can make the LED with this resistance. You can, however, increase the resistance to whatever you want, like as high as you want. At the highest end of the spectrum, then the LED just won't light at all. So what you have, if you see in your like Ian has, the bag with 1 LED and 1 resistor, this one is actually a 200 ohm resistor, just to be safe. And so you should be able to see that these things are color coded, but luckily I included it for you. So it should have a red stripe, 3 blacks, and a brown stripe, just in case you're curious about verifying. But yeah, Artem is ahead of the curve. That's what Artem is. Oh, too far. Oh. So if we go back to our, no, too far. Alright, I lost the slide. Anyway, let's go back to our circuit diagram. And so what we want to do is, the way we want to connect this is you should be able to do it with only 2 wires. And so yeah, before we plug it in or anything, we want to connect this first. And so what you'll have is you'll have your LED, and if we go back to what the LED is, the short foot is the ground. So on your breadboards in the negative side, you can plug that short foot directly into that, if you think about it. So Matt, I think, will go around and help people if anyone needs help configuring things. So this is the code that is currently running. So if you want, you should have an Arduino icon on your desktop. Yeah, you're already in it. So if you go to File, Examples, then Basic, then Blink, you will find the code for that. So some things to point out here. We have to, so with Arduino code, there are 2 main functions. One is the setup function, which initializes everything, and then 2 is the loop, which just continuously loops while it's on the microcontroller. So what you can do, so here we have initialized and said that our LED is going to be connected to pin 13 for the one that's blinking, and so during the setup, you just have to set up a pin mode as output, because instead we're not taking in sensor input, we're outputting to the LED. And then in the loop, all you have is a digital array to the LED and a high, which is specifies the voltage level. The comments are pretty helpful for this, which basically turns it on, a delay for 1 second to leave it on, and then turn it off again. So if you want to just play with this a little bit, you can play with the delays to change them around, or you can you can play with the delays, see how it blinks. You can make it steady. So now, second project, which is pretty cool, is it's a RGB LED. So what it is there's literally a red, green, and blue LED all within the same one. So in the same type of kind of additive color mixing that you can do in real life, you can do with the LED. So that will allow you to make all the colors of the rainbow in one LED, and then we're also going to be able to affect the brightness and do things like that. So once again, we have to use our Ohm's law to calculate the resistance, and so the green and blue can take a little bit more voltage than the red. So we'll just do our same math, and so these ones actually can have a low as a 100 ohm resistor. So now what you should find in your packet with the RGB LED is that you'll have 3 resistors. You'll need a resistor for each foot of the RGB LED. And so in terms of the color code, the one with the green stripe is the 150 ohm one. That is the one you're going to use for the red LED. And then the other two, you can use the 100. So this should allow these lights to get even brighter than we were doing with just our single LED. So if you want, you can remove your current circuit, and then we're going to set up this new one. Let me see if, okay, I actually have a circuit diagram on this one, luckily. So this will be easier. So something to take note of for the LED itself. It goes from the shortest foot is red, the longest foot is ground, and then it goes GB after that. So yeah, so definitely take out your LEDs and identify which is ground, which is R, and which is GB.
I feel like I have the dexterity to bend these.
Yeah, you should be able to bend them the same way we did with the other LEDs. Just put one directly in the ground, but
yeah. What I usually do is I just sort of like put the longest one in the breadboard. The funny is to do like
You said you have a circuit diagram?
I do. Are we ready for the circuit diagram? Boom. So this is our circuit diagram. You're going to have 3 resistors that go into our RGB and our ground. To make it slightly easier, added the exact resistors you need for each of the colors. So we're going to connect them to pins 4, 5, and 6. And you're going to, and you just need to remember to use the green stripe resistor for the red LED, for the red leg, the red foot of the LED. So, yeah, so work on that circuit. Let me know if you have any questions. So, for people still struggling to set it up, this is how I set up mine.
We need to open up other examples and see.
So you can see the RGB of the LED are all in the same column. And then you have your resistors. These are your pins and your ground. So what you want to do is you want to initialize 3 pins, and so you only have to do that in the setup. And then, so if anyone's about at a coding stage, I see that Don and Tracker Mike are. At least for me, as a basic thing that you need to do for the RGB that's different is that for the setup, you need to set up 3 pin modes for your 3 different pins for your red pin, green pin, and blue pin. And then what you can do is I set up just another function just called light red, where what you do is you write the full 255 to the red pin and zeros to the green and blue, and that will make it red. So and one thing I should say is instead of a digital write, it's now an analog write. Is the other difference from the blink example. So it's just about 1 now. So I want to move on to sandbox ideas. So obviously I showed that you can hack Christmas lights, and with literally just the code that you know now, you can make the Christmas lights dance and have tails and run into each other and all that sort of thing. Something I built recently was just a Gmail unread mail notifications. So when you start to get Arduino talking to other software like Python, it checks my unread email, and then it'll display a different color LED based on how many unread email messages I have. I know Mustafa was thinking about making some sort of get my attention LED, so while he's working, you can ping him and a light will just turn on, so he knows to turn around. You can build matrices out of LEDs. Any other thing that you can think of. And then just in terms of resources, the Arduino website, if you go to File Examples, has tons of different examples of code in terms of serial, lighting, LEDs. Also, you can do awesome things where you can buy Wi-Fi boards. You can hook them up to Wi-Fi and Ethernet, and you can make them communicate. You can plug in cameras. You can plug in all sorts of sensors. The thing with the K-Grader dashboard was called a flow meter. So it monitored how much volume of liquid went through it, and that would go back. A lot of people put things on like Hackaday, Instructables. I'm starting to put some of my my projects on my own coding blog. And then if you're ever looking to buy things, SparkFun.com basically has all the different things you could need, from the boards, cameras, sensors, resistors, anything. So that's it, guys. Thank you.